Do a new one. Okay. All I want to do for this next couple is just identify, is it direct variation or no? The way that we can distinguish direct variation versus not is if it has a y-intercept or if it does not have a y-intercept. Zoe, direct variation, yes or no?
Wait, what?
Does number 5 have direct variation or no?
Well, how would you know?
Does it have a y-intercept? What's the y-intercept?
No, then.
Well, I'm just asking. Well, you said yes, so does that have a, what's the y-intercept? Abby, help her out. Direct variation or no? Why? There's no y-intercept. So what's the constant of this problem right here? 3. Direct variation or no? Snow.
Direct
Why?
There's no y.
What's the constant of this one, Stone?
-4 over 5.
Very good. Connor, direct variation or no? No. What do you think? Yes or no?
Yes.
Think it is? Well, let's see. Let's graph that. So here's my y equals 2. Does it have a y-intercept?
Yes.
Yeah, it does. What can it not, if it has a y-intercept, then it's not going to go through the origin. If it goes through the origin, then there's no y-intercept. I just graphed that line for you. Doesn't that prove that it does not go through the origin? So therefore it's not direct variation. Okay, this one. This is not in the correct form yet. But I'm sure you guys are smart enough to figure out, how do I get y by itself? Divide by 2. Y equals 5 over 2x. Does this have a y-intercept? No, so therefore it's direct variation. It goes through the origin. Over here, does this have a y-intercept?
No. Yes.
Bennett, what is this right here?
Oh, -4.
That's a y-intercept.
Sorry.
So therefore it's not direct variation. Does this have direct variation?
Yes.
It is. What's my constant in that problem? -1. -1. Okay, right here. Not in good enough form yet. What do I do to this problem to figure out if this has direct variation? Not -2, Zandy, because they're being multiplied. We're doing the inverse operation here. So it's division. We're going to have y equals 1 over 2x. Direct variation? Yes. Over here, standard form. Still not there. Convert this to slope-intercept form on your own. Do it on your own. I want you to practice this. Convert this to slope-intercept form. We're on number 12. Steven, tell me what you got.
I got y equals 3 plus 3.
Y equals what?
2x plus 3. 2x
Do we agree?
plus 3.
Okay. Does that one have direct variation? No, because it has a y-intercept. How about mine over here? Y equals -5x plus 0. Direct variation?
Yes. Yes, it has. 0 is the y-intercept, but 0 means go to the origin.
He's right.
So it is.
He's right.
0.
0 is the origin. If it goes to the origin, it's good. 0 is just a number, but 0 is what we're looking for. If I go back to all of these, and I add a plus 0, does that change that problem at all? No. If I go up here and I add a plus 0, does that change the problem at all? If Carter has $10 and I say I'm going to give him $0, how much money does Carter have? So does it change anything? Okay. All right, so let's go to the next section. Okay, graphs. Very simple. All we're trying to do, ladies and gentlemen, is figure out, do these go through the origin? If they go through the origin, then they show direct variation. If they do not go through the origin, then guess what? They do not show direct variation. Colin, does this go through the origin?
Yes.
So does it have direct variation?
No. Then
Yes, it does. Ben, does this go through the origin?
No.
So does it have direct variation? No. Because by not going through the origin, what does it have? A y-intercept. Ian, does this go through the origin?
Yes.
So does this have direct variation? Yes. Addison, does this go through the origin?
Yes.
So does it have direct variation?
Yes.
Okay, good. Okay, with our last 7 minutes of class, it says finding missing values. Finding missing values. This is probably the most important part of all of this. Notice that it's giving me certain pieces but not the other pieces. This ordered pair, I have my 2 pieces. This one, I don't. Can we agree with that? I want you to write down everything I'm about to write down. I want you to see this. We are assuming that this is a direct variation problem. We're going to take that assumption when you see these types of problems. And the formula for finding direct variation is y equals kx. Because once again, we do not have a what? A y-intercept. Now, do you notice how I'm given these 2 pieces right here? I'm going to plug them in now. So I'm going to have -4 is equal to k times 2. Nod your head if you understand how I put that formula together. Now, I'm going to solve for k by dividing both of these sides by the number 2, making k equal to a -2. Are you okay with me on that so far? Anybody have an issue with how I found k? Now watch what I'm going to do. I'm going to take this problem and I'm going to rewrite it. Y equals kx. Now ladies and gentlemen, is this an x or a y value? So I'm going to plug in that -6 for x. Do we agree that if this and this show direct variation, this is a constant relationship the entire way through the entire problem? The very beginning of this, I said, a relationship that repeats itself through the entire ordered pair, no matter what change it is. So I'm going to take this k value, and I'm going to plug it in here, leaving me to find y. I use this first ordered pair to solve for k, the constant multiplier, my slope. You okay with that? Yeah.
How'd you get -2? Was it from that?
Yep. Literally had k, I solved for k, I got k was equal to -2, so I replaced my k in this problem with a -2. Okay? Now, -2 times -6 tells me that y is equal to 12. Okay, see a lot of confused faces. Where are we stuck? Nowhere?
You have to solve the first one and then
Well, so let me ask you this. Do you know what this y value is right here? We don't, right? The only way to figure out what that y value is to figure out what the constant multiplier is. By finding out what that constant multiplier is, I can substitute it into this same equation to find my missing value. If x is equal to -6 and the constant is -2, then I can plug it in to find y.
would it be the same for like the x?
Absolutely. Except for if I was looking for the x value, Brian, I would have an x variable here and my y value would be plugged in. Let's look at number 2, what Brian just asked. The formula is y equals k times x. Okay? Do I have a y and an x value? Okay? My y value is what? 16 is equal to k. What's my x value? What am I looking for in this problem? Right here, what am I trying to solve for? How do I get k by itself? Divide by 4. That gives me that 4 is equal to k. We're all right there? Okay, now, I'm looking for this x value right here. So if I go over here, my formula is still y equals k times x. I'm missing the x, means I don't know what the x value is, but I know that the y value is 24. So I'm going to have 24 is equal to, well, we just found that k was equal to 4. How do I get x by itself? Divide by 4. X equals 6.
Isn't that the same thing you do to find the constant?
Yep. So instead of dividing by the x to find k, I'm dividing by the k to find x. All right, drop down here, number 22 with me. The formula, once again, is y equals kx. We're all on board with that. If y equals negative 18, when x is equal to 3, you see how I plug those in? Y equals negative 18, x equals 3. How do I solve for k? Divide by 3. Therefore, k equals a negative 6. Now it says, find x when y equals 30. Well, it's the same thing. Y equals k times x. 30 equals negative 6 times x. How do I solve for x? X equals a negative 5. Okay? All right, hey, I've recorded all this. You guys do have homework tonight.